Hello, this is a video which I will discuss about bandpass modulation. In the last video, we saw what is a baseband modulation. The different encoding schemes that encodes data according to whether you give a positive voltage for 1 or negative voltage for 0. We learned several techniques like non-return to 0, return to 0, bipolar, polar, unipolar waveforming signaling formats. All those were part of baseband data transmission. Baseband data transmission primarily means the transmission at a low frequency. A baseband signal is a signal that is centered around a frequency f is equal to 0. Here we will discuss about a bandpass modulation. So bandpass modulation is, as the name suggests, there is a particular band of frequencies through which this signal will pass. First, let me say the motivation behind bandpass modulation. All channels have a limited frequency range that will support wireless transmission. So the baseband signal should be modulated to a higher band of frequency to be suitable for transmission. Then we will learn some common forms of passband modulation. They are ASK, PSK, FSK. ASK stands for amplitude shift keying, PSK stands for phase shift keying, and FSK stands for frequency shift keying. So we are not able to practically transmit a baseband or a low frequency data to higher distances, and also we want to modulate the baseband data, the low frequency data, so that it will shift its position to a higher frequency band. This has a lot of advantages which you would have already learned, like a higher frequency will reduce the antenna height, it will enable frequency multiplexing of the signals, and actually a lot of advantages which due to limitation of time I don't want to say now. Presently let us see different types of bandpass modulation. So practically all channels are band limited. They have a particular range of frequencies that passes. No channel in this world passes all frequencies. So all channels in general can be considered as filters that pass a particular band of frequencies. Let us quickly review what is ASK, amplitude shift keying, phase shift keying, and frequency shift keying. So it is called keying. Why? Because according to the incoming signal 0 and 1, the carrier signal, which is a high frequency signal, it changes its parameter, amplitude, phase, or frequency. It changes its parameter according to the incoming 0 or 1. So naturally you are actually keying the signal from 0 to 1 and 1 to 0. For example, in amplitude shift keying, if 0 is the incoming signal, then you don't have any voltage here, it is 0 volt. If you have a binary 1, you have a high frequency carrier. In phase shift keying, instead of amplitude, the parameter phase is varying. If you have a change from 0 to 1, you have a change of 180 degrees. So the phase is being changed according to the incoming signal. For binary 1, there is no change, and for binary 0, there is a change of 180 degrees. Now FSK, it is frequency shift keying. According to the incoming signal, you have two frequencies here. If it is a binary 0, you have a low frequency. If it is a binary 1, you have a high frequency. So these schemes essentially they say binary ASK, binary PSK, and binary FSK. So why I call it binary? The incoming signal is either a 1 or a 0. Now, in order to have a better understanding of these concepts, let's analyze the constellation diagram. So first of all, what is a constellation diagram? A constellation diagram is a diagram that shows the signal as a point in signal space. The constellation diagram has coordinates: x coordinate, which I name it as in phase component, y coordinate, which I name it as a quadrature phase component. In case of BASK, if you want to draw the constellation diagram here, we need to have just one carrier, and the carrier is a cos 2 pi fct for binary 1, 0 for binary 0. So you have 0 and 1 here, and you have just one carrier, and this axis, it represents one carrier. Amplitude shift keying is also called on-off keying. Now the constellation diagram of BPSK. BPSK has two phases according to the binary 1 or 0. Here it is shown that for a phase 0 you have minus root e, and for a binary 0 you have minus root e amplitude, and for a binary 1 you have root e amplitude. The reason for root e minus root e is a phase shift of 180 degrees, and as different from the amplitude shift keying, here you have only one carrier, but for phase shift keying you have two carriers, phi 1 of t and phi 2 of t. When learning the constellation diagram of BFSK, binary frequency shift keying, we have two carriers along x and y axis, and here you can see root. Here you can see there are two carriers along x-axis and y-axis, and these two carriers, they contain two different frequencies, and of course you can see these signals are orthogonal to each other. You have a 90 degree here, so they are orthogonal to each other. So you have S0 and S1 as two symbols. S0 can stand for binary 0, S1 can stand for binary 1. You have a root e magnitude for both, and these signals are identified at the receiver on the basis of what is the frequency of the incoming signal, whether it corresponds to this carrier or whether it corresponds to this carrier. I know most of these concepts are not really clear from this short discussion. However, interested readers can go for standard textbooks in digital communication and understand the concepts in real depth. Thank you.